going to look at differential equations using the separating variables uh, method. Here, if we have a dy dx, that is this derivative, where this derivative is of the form of f of x over g of y, that is a ratio of two functions, then we can rewrite it like this. Put the gy on one side and f of x on another side, so we get these particular equations. Now, if we take the integrate both sides, then using chain rule, this line of differential equations is reduced to g of y dy, that is integrate g of y separately with respect to y, and integrate f of x with respect to x separately. So this is the idea. So now let's look at this particular example, how we can do this. Now here, you can see that there can be separated, the x and y's can be separated by itself. So we start by writing dy over y squared, just put all the y onto one side and all the x on one other side. And here, notice that I am using the derivative as if it is a ratio. Okay, so this is what we're going to have. So this is with respect to dy, this is with respect to dx. Over here is just negative 1 over y, equal to, over here is natural log of 1 plus 2x divided by 2 plus ln c, for example. Right, ln c, for example. So this particular thing then can be re-simplified as natural log of 1 plus 2x to the power of half times c. And here's negative 1 over y. Or in other words, this is y equal to negative 1 over natural log of 1 plus 2x to the power of half times c. Alright, so now I need to use this boundary condition. Y of 0 is equal to 1. That is 1 here, negative 1 over natural log of 1 plus 0 to the power of half times c, which you can see this is negative 1 over natural log of c, for example. Alright, that is ln c now is equal to negative 1. So c must be equal to e to the power of negative 1, or 1 over e. Right. Therefore, my equations then will be y is equal to negative 1 over natural log of 1 plus 2x to the power of half times e. So here's my answer. Alright, let's look at another question. In this question, we need to show that this particular ratio can be written as two different ratios, that summation of two different ratios. This particular technique is right, so we have to do this. So first part is just 6 minus x over x squared minus 1. So what we do is that we treat this, say that we can actually write like this. So this is by comparison. So we actually assume that it can be written like that. Therefore, you can see that the denominator is exactly the same. The numerator now is ax plus a plus bx minus b, or in another word, this is a plus b x plus a minus b. So by comparison, then we can see that a plus b must be equal to negative 1, or a is equal to negative 1 minus b, so for this equation number 1, and the second equation is a minus b is equal to 6. So I can replace equation number 1 into equation number 2. So put or substitute 1 1 into 2. So I will have negative 1 minus b equal to 6, or negative 1 minus 2b equal to 6, or 2b equal to negative 7, b is equal to negative 7 over 2. Now, if you know this, then a can be calculated as well. A, from here, from this part, a now is negative 1 minus minus become plus. So that becomes 5 over 2. Therefore, what we have then is 6 minus x over x squared minus 1 can be written as 5 over 2, right? And then x minus 1 minus 7 over 2 x plus 1. So this is what we have. Then the next thing is that, well, let's go back to the equation. What the b part, we need to solve for dy dx here. So solve for that means that dy dx is equal to, here the common factor is y. So y of 6 minus x over x squared minus 1. Therefore, we can see that we can separate the variables, dy over y, integrate equal to integrate 6 minus x over x squared minus 1 dx. And by using these two fractions at the bottom here, here is natural log of y. Over here is integrate 5 over 2 x minus 1 minus 7 over 2 x plus 1 dx. Alright, so what we're going to get is, this is natural log of y. Over here is 5 over 2 natural log of x minus 1 minus 7 over 2 natural log of x plus 1, and then plus natural log of c. So basically that's the answer. Now, before this is not completed, we need to still solve for this boundary condition. So that means I can combine this thing together. Lny is equal to natural log of big bracket. Alright, in here, in there I will have x minus 1 raised to the power of 5 over 2, and then times c over, this is x plus 1 raised to the power of 7 over 2. Right, so extend the page a little bit. So natural, what the boundary condition is this. Y of 0 is equal to 1. That means I'm going to have, right, natural log will go away. So this y is equal to x minus 1, 5 over 2c over x plus 1, 7 half. And I want this to be 1 when x equal to 0. So negative 1 raised to the power of 5 over 2c over 1 raised to the power of 7 over half. And we can see that in this case, c has to be a negative 1. Therefore, my answer is y equal to x minus 1, everything raised to the power 5 over 2 times 1 over x plus 1 raised to the power of 7 over 2. And here is my answer. This is the answer here.